Hello everybody, and thanks for joining our HERIOS Sensors webinar today, The Power of Temperature Sensors in E-Mobility Applications. The developing e-mobility market is extremely appealing and holds great promise, offering many opportunities. Therefore, reliable temperature sensing is the key to grow with the market and profit from it. Let's learn more about HERIOS Sensors' current activities and sensor solutions for applications in power electronics, e-motors, and charging applications. My name is Lisa Bürke. I'm from the marketing communication team, and I will support my colleagues today during the webinar. A few general information up front. So the webinar itself is planned to have a duration of 1 hour, which includes a Q&A session afterwards. Please note our session today will be recorded and used for internal trainings. The record will be available for you afterwards as well. Regarding the settings, all attendees are muted by default. If you have any questions, please address them in the chat box you can see on the right-hand side, and I will address them during the presentation directly or collect them for the Q&A session afterwards. So due to data protection policy, we are not allowed to address any specific individuals to keep you anonymous. If there are detailed questions, please come back to us afterwards via mail or phone. Also, make sure that your audio works. Our recommendation here is using the headset. Another option is to dial in via phone. You receive the recording information via invitation mailing. Also, please note our speakers are vaccinated, boosted, and tested negative of today. And now I hand over to my colleagues and speakers today. Dr. Christoph Hartnick, VP Business Development, mainly responsible for new products and new applications, and Mr. Martin Bleifuß, who holds the position of Global Head of Application Engineering. Thank you.
Thank you, Lisa, for the kind of introduction. Welcome. Good morning to those dialing in from the US. Good afternoon from our guests from the Asian area. Welcome from our side. We will talk in the next 45 minutes mainly about 3 focus topics in the e-mobility where we as HERIOS Sensors are active in. This is first power electronics. We will then focus on e-motor applications, and finally safe charging or the safe charging infrastructure and charging equipment. Certainly you will have the opportunity to ask questions. As mentioned by Lisa at the beginning, please feel free to ask questions anytime via the box, and we will collect and answer them latest at the end of this webinar. For the beginning, we will get you a quick introduction how we at Nexensos address new topics and how we structure our development activities. Coming from megatrends, we look into specific topics like renewable energies. Kind of key focus here is hydrogen, as an example. Then we take a look at pollution control. One of the megatrends that we see nowadays, gas sensors in terms of sensing play an important role. Health and IoT in general are questions where miniaturization plays a very important role, especially for sensors. Having these sensors anywhere or everywhere is one of the key focus questions which we see in Industry 4.0. Combined sensor platforms, another approach to the sensor industry. And finally, and this is why we are here today, e-mobility. For e-mobility, in this e-mobility segment, we see basically 3 areas of interest. These 3 areas will also the structure for the webinar in the next minutes. We start with the power electronics, focus on the trends in the power electronics, like trends to high temperature semiconductors like silicon carbide or gallium nitride, operation at high frequencies. Another topic is electric motors, electrification of heavy-duty vehicles, commercial vehicles, and finally charging equipment requirements that we see from higher charging powers. In the first step, as mentioned, we focus on the power electronics. We see the trend to new materials like silicon carbide, like gallium nitride.
Yeah, hello. Also from my side, I'd like to say something about the technology behind and what is necessary to work with these new materials. First of all, to higher the efficiency in the power world, more or less, you need new materials, like Christoph mentioned, silicon carbide and gallium nitride. These new materials are able to work at higher frequencies, which leads automatically to higher temperatures. And as a result, you need for sure also different or new technical solutions for packaging. That means sintering, silver sintering. Yeah. This new technology enables also our customers to work on new designs and with optimized processes like sintering in general, which is then the key that you don't need a kind of a cleaning process after the connecting process. That means if you work with sintering, you don't have fluxes in your process, you don't have cleaning steps in, which is design-wise a real step forward. Yeah. And more accurate temperature sensing technologies are also required, and this leads to come very close to the temperature limits. And with our technology, with the SMD type PT sensor, which is for sure a sinterable solution, we are able to come very close to the heat source. That means we are fast, we are very accurate, and we are potential free, especially in the position on the board of our customers.
Some words regarding general trends that we observe from the point of temperature sensing. We see this trend to these higher switching frequencies, and we see the trend to higher power requirements. Gallium nitride is typically used in telecom applications. We see areas like the entire sending, the antennas, broadcasting, everything is done at higher switching frequency. On the other hand, we see silicon carbide. Silicon carbide is the prevalent or dominant technology nowadays in modern and state-of-the-art electric vehicles, hybrid electric vehicles. We see silicon carbide also in railway applications and certainly in electrical grid markets.
Mm-hmm. If you look at that graph, hopefully you can see maybe my pointer. There you can easily check that if you higher the power, that means you look here on the watt, silicon carbide is more and more interesting. That means if you higher the voltage you want to transform, the higher the power you want to deal with, the higher the temperature is in the end. And with a typical IGBT silicon situation or solution, it's not possible to work with temperatures over 170 degrees, which is easily possible with silicon carbide. If we look on the gallium nitride situation here, it's a bit different for sure. We work not directly with higher power, but we work directly with higher frequencies for the switching. And if you switch very often in a very short time, this leads also to increased temperature. And this increased temperature is in the end also the problem. And this is the reason, or this is why we solve that problem by sintering. And both of these technologies are key for the future trends. That means if it comes to higher transformation of power, you need silicon carbide. If it comes to higher frequencies for switching, it comes to gallium nitride. One is more or less for the automotive world, the other is more for the telecommunication market, but both leads in the end to higher temperatures, which is then optimized, controlled with the sensor from Helios with a PT element.
Some words about the market that we expect here. We see, as mentioned, this trend to silicon carbide in the automotive market. We see a shift to silicon carbide, what we expect latest in the next 8 to 10 years, is more than 50% of the power modules will be equipped or based on silicon carbide. So there's a huge market ahead. This is the reason why we focus on the silicon carbide technology and look for applications to broaden the application range and to enable these high performance power electronics. Higher operating temperature requires a more accurate temperature monitoring. One factor which we would highlight here is the distance, that is what Martin mentioned already, distance between the temperature sensor and the heat source. In case of power modules, it's the power die. We started to look at this point to design a sensor and to develop a temperature sensor starting from a modeling perspective. We looked at a setup where we have the possibility to position the temperature sensor very close to the power die and try to see the difference whether there's an edge branch or not. So looking at the effects of another technology, which can be contrary to existing technology, brought even closer to the heat source, therefore allowing for faster reaction times and for faster and more accurate temperature detection. What we see here is by shifting the distance or by reducing the distance between the temperature sensor and the power die, we see that we get even more accurate in terms of representing the temperature of the power die, and looking at the effects of the edge branch, we see that there's a substantial drop in the temperature that we detect that reflects also the potential and possible accuracy.
If you look on that graph, it's easy to understand that if you're on the left side, you have really good idea what the temperature of the die is, and this is really essential to protect the die. And on the other side, if you are in that area where the edge branch is interrupting the heat transfer and so on, you have only a rough idea about the temperature. If you take into account that a lot of effects like edging and so on even reduce the performance of these connecting technologies, it's essential to come close as possible to the heat source. This is what Christoph mentioned before.
So in general, what we can state here with a new sensor design, with a new sensor layout, we managed to reduce complexity of the substrate, we managed to reduce edge branches, and we allow for a close position of the sensor next to the power die, which means faster, more accurate temperature detection and a reduced complexity of the substrate. Martin will tell in more detail about our temperature sensor and will demonstrate and explain the different parts of this temperature sensor.
You see in detail the design of our sensor. We have different functional areas in the middle. What is highlighted here, you see the meandration, which is a platinum resistance thin film. And this is optimized for a very stable signal over a long period of time. And the operation window is for that meandration only on a substrate like aluminum oxide or glass or something like that, up to 1000 degrees. In our application here for the power electronics, it works quite well, also over 200 degrees. The limitation is on the other side. That means, please, the next step. We talk about the connection, the topside connection, where we use bonding wires. These bonding wires are at the moment state of the art in the electronic world, especially for the power electronics. And here you have a fast and reliable connection technology in use, where we work at the moment with aluminum thick wire, 300 microns, available at Herios from the Herios Electronics. On this side, we see, or on the back side, we have a silver layer, which is ready for silver sintering. This silver layer is made for an optimal thermal coupling, and this leads in the end to a very, very good response time, which helps us to react very fast to protect the power dies. Yeah? The material itself, where everything is on, is aluminum oxide. This aluminum oxide is an electrical insulation material, which allows us to work potential free. This is what we mentioned some slides before, that we can position our temperature sensor, yeah, more or less everywhere on the top side of that DCB, for example, or any other substrate which is metallized. Yeah, that means with that potential free positioning, we have the chance to work directly with it, but we have for sure some limitations about the electric strengths. Typically, our customers pot the complete surface of a DCB with an epoxy, with a silicon, with, yeah, this is more or less their know-how, how they can cover the complete board in that situation to protect it against the electric effects. Talking a bit about our data sheet. We have a packaging size of 1206. It's a typical SMD packaging description. I highlight a bit later what that means. We have a nominal resistance of 1000 ohms, which is at the moment state of the art for this technology, and our customers ask for nothing else at the moment. Yeah, the temperature range is, like mentioned before, -50 up to 200 degrees. The limitation is at the moment only the topside connecting technology, in that case the aluminium wire. If you are able, if you want to work with different other topside connections, please get directly in contact with us. We can talk about a lot of solutions which we have also in mind, but this needs a better clarification in the end. The tolerance class is at the moment the 2B. Typically we produce a B version, but this is only because of some effects we sometimes see with the silver material, which is here a lot in. The TCR is 3850, and the measurement current is limited with 0.1 up to 0.3 because of self-heating effects. Yeah. We made a lot of tests. These tests are in coordination or made in coordination with a lead customer from us who is out of the power electronics world to take care about that all these tests are the right tests. Yeah, that means we have a high temperature storage, 1000 hours, 200 degrees passed, everything is fine. Low temperature storage up to -50 degrees, 1000 hours also passed. We cycle our system -40 up to 150. Test passed, everything is fine. And a really harsh test is an unbiased humidity test. We made a 85 degrees test with an 85% humidity, and typically a lot of components will fail under that test, but our sensor passed also that test. And in the end, we had an operational live test, 1000 hours, really biased or with 0.1 milliamperes and at 200 degrees, and also this test was passed. That means this is our understanding of quality. Speaking about the sensor itself and how we deliver it, quality for sure is our main topic. And here you see in the beginning the dimensions. These crazy dimensions 3.1 are coming from the inch world. That means our naming is based on the US electronic standards, and 1206 means 12 or 0.12 inch in the length, and this is 3.1 millimeters, 0063 inch in the width, which means 1.5 millimeters in the width. And this is the reason why the naming is SND 1206. On the left side, you see how we deliver that that sensor system to our customers. We have a singleized situation. There are a lot of chips on that wafer frame, on that sticky tape, and we speak about 360 up to 450 pieces per wafer. And we put that wafer into a plastic bag, which is metallized, and evacuated in the end to protect it in the best way for more or less oxidation. We do also some tests at the moment. We are delivering it in a blister reel because some of our customers ask for this special packaging to make life easier for them. We do a lot of tests at the moment, and at the moment we are in the final validation and testing phase because, as I mentioned before, quality is our key topic here, and we try to save our customer for failure parts.
So after the excursion to the power modules and our offerings for power electronics, we take a look at the second application area, which are electric motors. We already highlighted the key trends that we observe here: electrification of heavy duty and commercial vehicles, especially for inner city supply, but also for long haul trucks. This becomes more and more important. In addition, we see another trend for passenger cars. Car sharing or shared driving results in longer operation times. If you consider and if you compare typical operation times of a passenger car, which is in the range of 5,000 to 6,000 hours over the operational lifetime, we see much longer operational lifetimes at the moment. This impacts the stability of employed components. This creates a requirement for long-lasting components. Based on these trends, we see certain need for adapted components, for improved components in terms of reliability, in terms of accuracy over long operational lifetimes. High torque engines require a fast reaction time, a fast response time. They have to be protected against overheating. Mounting becomes crucial. Replaceable or permanent mounting options, that depends very much on the preferences of the end customer and the specification of the OEMs. And finally, our solutions have to be flexible in terms of application, whether it's a wound stator or a hairpin stator.
Yeah, as Christoph mentioned, long operational lifetimes. Why we see that? We see, different use cases. A lot of car sharing models are in the minds of our management guys, and these car sharing models, leads to longer lifetimes of the vehicles in general and to different use cases. This is the reason why we need long operational lifetimes. The response time is also very, very important. If you think about cars parking with wheels directly at the curbstone, the torque you need to roll over that curbstone, leads to very, very high temperatures in a very short time. This is the reason why we need fast response times to protect that complete e-motor for overheating. Because what is happening in a e-motor, if there is an overheating effect, it destroys the insulation varnish or the lacquer, and the magnetism of the magnetic materials is also in the end destroyed, and this leads to a problem. That means the motor is out of order, and it's one of the high and very expensive parts in the car. Our temperature sensor solution, especially with the mounting, has the special offer to measure the temperature very fast. We have a drift-free situation. That means the temperature stability over a long time is given, and the mounting options are for sure always more or less customized, but we show you some different solutions for that. If it comes to a very popular solution at the moment, we have that EC3032. This crazy name is because of the dimensions, but in the end you see a round-shaped head. We call it tip, and this is really made for e-motor protection. That means it's really designed for the e-motor applications, especially for EV cars. We have here a round sensor with an head which is optimized for these wound stators. That means this is not a hairpin technology. This is the traditional e-motor design. It's really robust, in terms of the encapsulation. That means we have more or less flexible solution in the tip. That means it's not brittle. This is really good for an environment where vibrations are usual. and this solution sends out a stable signal over years because of the PT technology. For sure, this tip, that means length, diameter, also the design is customizable. That means, I will show later what that means. Yeah, if we speak about the precision in that situation, we have also included a PT 1000 with the typical TCR. We have a tolerance class of B available. We have a protection against humidity and things like that with IP67 standards tested, and also IP68. And oil resistance is also an important thing I want to talk later about and show you what we made to that topic. The temperature range is not limited by the sensor itself. It's more or less limited by the materials of the cables, of the tip protection, and so on. But we are able to work up to 200 degrees, short term also 250 degrees. The dimensions, this is why it's called EC3032, is the housing length of 30 millimeters and the diameter of 3.2 millimeters. And the cables are in this situation a semi-rigid fluorocarbon cable, and the isolation is a PDFE insulation with the 24 AWG. But this is all discussable. That means if you need very special things, we can talk about. Yeah? The cable pull force, this is also a very nice indicator how good is the connection between cable and sensor, is here at 100 newtons, which allows to work with that system in a very good way. The specification, the electric strength and so on, is tested with 6,000 volts and an alternating current, and it's measured for, or it withstands that situation for over 60 seconds. Yeah, we have that solution over a long time in market for these e-motor applications. We started in industry applications. That means we know a bit where we talk, what we're talking about. Coming to the next EC3032, but here in a modified design, more or less. We have here that modified version in a flat tip or with a flat tip. That leads to a very, very good connecting situation if it comes to a flat temperature sensing element. That means if you have in mind, and as it's shown here on the right side, that hairpin technology where not round wires are wounded. Here we have these flat hairpins, which looks more like a bar. We are able to push or to press our very flat sensor on top of that bar, and the heat transfer is optimized over an area, not over a line. Yeah, this helps us to have here really good response times, and we see how that could look like in a graph later. Temperature range comparable to the standard version, also the electric strengths and the customization we talked about. Wires and everything else is more or less discussable, but we have also standard version for an easy access for you in our store.
When talking about thermal response time, it's always good to not only talk about theory, but also about practical results. What we did here in order to compare the round head versus the flat head on a hairpin-like situation is we made a kind of temperature jump tests. We put the two different sensor types on top of a hot plate. So that means having a temperature jump from room temperature to an 80 degrees hot heater plate, and then look how fast the sensor reacts, how fast the signal changes going from the room temperature to this elevated temperatures, and look how fast we can reach the 100% or the 90% accuracy. And this is what you see here on the right side here in gray. It's the standard round head element, and in orange you see the modified, the adapted for hairpin motors. And what we see is by this advanced design, we managed to improve the response time, we managed to improve the speed of temperature detection. That means response time reduction of up to 30% is possible by the geometry of the sensor head. That allows for really a very fast and also very precise temperature sensing, especially for the next generation of hairpin motors. We create the basis for performance and reliability and bring our contributions to make your applications more efficient and safer. Martin will tell you something about what we think is very important. It's the oil resistance and how we tested that.
Mm-hmm. Yeah, a lot of customers ask for oil resistance. Why do they do that? Yeah, these customers work typically with a special cooling liquid, which is more or less an automatic transmission fluid. Yeah, we know it from this application. And how to come to an answer if we are oil resistant or not, we do a very simple test, as you can see here in that picture. What we made is we took our sensors, a lot of these sensors, into a pot of automatic transmission fluid, which we heat up in an area of 100 up to 140 degrees, and we have an exposure times over 21 days. In sum, we heated up the complete situation 100 hours and cooled it down over the night, as it's usual in the typical use case, because the car is typically in the garage in the evening. Yeah, and in the end, you see on the right side the test result. You see the results before test and after test. You cannot really see a difference. This is the reason because there is no change in between. Yeah, all these tests were made passive and active. That means powered and without power, and all lead to the same result, which is fantastic for us. That means our system is quite good sealed and ready for sensor application in motor application with oil.
So Martin, here's a question.
Yeah. Okay.
So the question is, what kind of transmission fluid did you use? Are there several tests for several fluids?
Yeah, no, we had a focus on one oil because this was mentioned by one customer. We know that there are a lot of different fluids are on the market. Hopefully, the difference is not so hard or so big, but we started with one oil. If it's very interesting for you, I can give you also the oil type after that meeting. Please write me an email and I will send you in which fluid with which fluid we worked. But for sure, this test is also we can also do that with a different oil. But yeah, allow me that situation or to explain the situation. There are so many oils in the market, and if you do this test with all of the oils, it leads to 200 years of development. This is the reason. If you have a special oil type in mind, let's talk about, and then we can do something, or maybe we have the right oil.
So another question was raised up. Is the IC mod also IP67, IP68, and oil proof?
Yeah. Yes, it is. Yes, it is. We also made the test with these modification types or modified types. This is also possible. Yeah.
Lisa, more questions before I flip the
No more
slide?
questions.
Yeah.
No more questions. Thank you.
A sensor is just as good as the mounting options. This is why we developed a new type or new way to mount these sensors. We want to ensure we have a stable connection that should be easy to mount, and depending on the requests of our customers, being either a permanent or a replaceable option. And Martin will tell you quickly about what we did in terms of development and how to ease the processing and the mounting of the sensor.
Mm-hmm. Yeah, we have different requirements. Some of our customers want to have a replaceable version, others a permanent. If you talk about a replaceable version, there are also differences available. We can create a replaceability from the outside of the housing. That means the sensor could be replaceable with a screw and a lot of different materials from the outside. That means you can screw in that sensor and I don't have a picture here in my presentation from that because this was customized for one big customer, but we can talk about your ideas and put together our heads to create a solution for you. But what we see here is a replaceable version on the winding directly, and you can use this replaceability as a kind of a repair situation. Yeah, we call it a slide-in sensor. Yeah, how is that working? We take two rods or chopsticks, you can call it however you want, and put them into a shrinking tube on the end, as it's shown here. Then we fold the shrinking tube to a position like it's shown here, and between the gaps of an hairpin, we slide that complete system in, as it's shown here. And in the end, if it's slided in, we take a heat gun and shrink the material for fixation directly on the hairpin. That means then the situation is really well connected. The surface is pressed down together. That means our sensor is in a very close contact to the hairpin at this situation, or shown here. And this leads to very good response time and so on. And in the end, if you have a trouble with a sensor, which is typically not possible with a real sensor, and then you can open that e-motor housing and plug that sensor out and mount in the same way a new sensor, which is typically in the historical mounting devices not possible because they work with glue, with some very special materials which are sticky, and in the end they are hard and brittle. And this is, in our eyes, a very good solution which we can show you. Yeah.
So here's also a question, Martin.
Yeah.
Does the overmolding material withstand the entire temperature range from -50 to +200?
The overmolding or
the overmolding material?
Yeah, it withstands that temperature for sure. Yeah, we tested that.
We did long-term storage tests.
Yeah.
With even temperature spikes of going to 250 degrees for 50 hours. And believe in me, the battery will be empty before the 50 hours will be reached. Therefore, we strongly believe that the stability, even at 250 degrees, is good enough to keep the material alive over.
But the question is really relevant because these materials are typically degrading in temperatures over 250, and then there is a discoloration with yellow and so on and so on. But all these tests are made with temperature spikes up to 250, and typically we made the long-term reliable tests in a temperature range up to 200 degrees.
Okay, let's take a look at the time and look at the agenda. Time for charging our car. That means finally we would like to take a close look to the charging equipment. There's an omnipresent trend to high charging power. If you look at for example, Tesla's supercharger network that is being built up along the highways, we see trend towards 100 kilowatt, 200 kilowatt, even up to 350 kilowatt. But increasing charging time means also increasing charging powers and, unfortunately, increasing risks. Even small resistances in a charging plug due to loose contacts, for example, can cause local temperature increases at the connectors, which really pose a threat to the entire charging infrastructure. In addition, there are new regulations discussed. One example is the GB 20234.4 in China, which made temperature sensors and sometimes even platinum temperature sensors mandatory in charging plugs and charging connectors. This open point of whether platinum-based will become mandatory or not is still unresolved, but in some we see a strong trend towards an even tighter temperature monitoring in charging equipment. Following these trends, we see the requirements for the application. We need a reliable and a drift-free temperature surveillance. That means even if we increase or if we have the temperature spikes, we have to make sure that the temperature sensor gives a stable signal over the long operation times. Miniaturization is an important requirement. We see that temperature monitoring solutions or sensor solutions have to be very close to the potential hotspots to make sure we have really short response times. And then, as mentioned, we have to make sure that the solution that we choose or that our customer choose are stable and safe towards new standards.
Yeah. Our temperature sensor solution stands for fast temperature sensing because we measure there where the heat source is located. The drift-free signal is because of our basic physics in behind. That means the PT element is in general very, very drift-free or stable against drift. And how we can assemble this to the plugs and connectors we see in the next slides. Here are some different ideas for mounting with the screws. In the first two pictures, you can screw in directly in the metallized area of that pin, which leads to a very, very good heat transfer. We can also use in the middle part of that slide, more or less, again, a kind of an EC3032, maybe in a different dimension, to put it directly in a hole in the core of the pin, which enables us to measure the temperature exactly where the heat is generated. And on the right side, you see, we call it a PCB version, which is directly mounted on the backside of a pin with a heat shrink tube. In the next slide, you see that this is not only an idea. You see directly the PCB type, which is mounted with a shrinking tube around that metallizated back part of the pin, and you can directly measure the temperature. And on the right side, there are some tests we made with the core positioned sensor. A lot of customers, or some of our customers, have also special ideas in mind where they put our SMD type directly on a PCB, and the connection to the PCB or between the PCB and the pin is then for sure covered by a pattern. This is the reason why we can't show you this solution, but in general we can say that our SMD or our PT sensor in general is really high reliable, and this is the reason why a lot of our customers trust in this solution.
So the next question came up to that topic. How do you ensure electrical isolation of the sensor in the fast charger applications?
Yeah, this is a very good question. This is why I mentioned that solutions which are covered by a patent, there are a lot of tricks included. If you see the solution here in the picture where our PCB version is connected, on top of the metallization, and around it is a shrink tube only for fixation. There is maybe a limitation because of the dielectric strength. This is the reason why we made some tests putting a very, very thin layer of polyimide foil in between. That means this generates then the right insulation to answer your question more or less. If you see the solution on the right side, you have to deal with very special pastes and materials to overcome that effect. But this is exactly the right problem, the biggest problem in that application. You deal with high power and you have to protect the system for this high power, otherwise you will destroy that.
Okay, another question to that topic. How do you ensure magnetic field is not affecting the readings?
Nice question. We had that question, and we had, honestly spoken, not really a good answer for that, but we made some tests, and we see that magnetic fields really don't have an influence on our sensor. We could overcome, if there is an effect in special applications, we could overcome that effect by a better positioning. That means if we do a special design of the miniaturization, we can overcome that. And we can also work with a special cable, which is then protected, and so on and so on. there are some design tricks you can use, but at the moment, a lot of our customers work with a standard sensor and they don't feel and see any effect. Yeah.
One comment here to add is we see different materials, whether it's an NTC or a platinum type sensor, and the advantage of platinum is it's less prone to magnetic interception, or susceptibility. So that means already from the materials that we employ, we have a lower and a reduced susceptibility towards magnetic radiation. Okay, then finally get you an outlook to what we are doing, how we try to optimize temperature sensing in charger plugs. Innovation is key for Heraeus Next Sensors. We try to get even closer to the critical spots, and if we take a look here in this charging plug, we try to get where there's a potential risk of a hotspot. So you see here the connector. And our latest development, it's a miniaturized temperature sensor, can be brought in directly in this to the very tip of this connector. It's what we call a sensor, our micro RTD. It's a sensor which is just 40 micrometers high. This can be placed directly at the top here. It's in closest distance to potential hotspots, and we ensure by this a maximum detection speed and an increased safety for a very close monitoring of our charging equipment. With this, we would like to close. We would like to give you a close look at where we are. We have a global setup. We strive to be as close as possible to you. We have our headquarters here, where we are currently located in Klein-Ostheim, in the south of Hanau. We have a production site in Germany. We have production sites in Malaysia. We have an application lab in Shanghai, and for sure we have our sales team positioned all around the world, close to where you are and close to where we need to support you. We would like to close this outlook to the e-mobility, to this new growing market. We provide the expertise and the right competences to support your e-mobility applications with innovation power and production capacities. And we would be happy to talk about your requirements, your questions, and give the right answers. Thanks for your attendance.
Because of the limited time, you are also possible, or it's also possible for you to send us some emails or to give us a phone call after that session if it's not enough time. Now it's not the end of the day. That means we can get in contact even after that call, or tomorrow or next week, whenever you want, or if you face any kind of problems we only touched in that presentation.
Okay, then thank you so far. Several questions already were raised up. So
Okay.
now, please address, if you have further questions, please address them into the chat box, and we're happy to answer them directly. No more open questions. That's also nice.
Cool. Looks like a well-filled presentation. Thanks again. And these are some closing words from your side.
Thanks for your time. Thanks for joining. As Martin already said, if you have any further question, please come back to us via mail or phone directly. We are happy to assist you, and thanks. Have a nice day.
Thanks for your time. Bye.